Welcome to Lesson 7.3, Scientific Notation. This lesson is going to be an examples of ways to show numbers. Once again, we've already taken a look at expanded notation and standard notation and word and number notation. And this is just going to be one more example of how a number could be represented with numbers. At this point, I would like you to go ahead onto my website and take a look underneath the extra support for lesson 7.3. I have a scientific notation song that I found that is a lovely song in Miss Fontek's eyes. So go ahead and view that. I'll give you an idea of what we're going to be talking about today. If you are already coming back from taking a look at that video, I hope you enjoyed it. I hope you're understanding a little bit more about scientific notation. But before we can go ahead and get started with our lesson today, I need to start out with a joke. What did the 0 say to the 8? Once again, what did the 0 say to the 8? Well, of course, he said, nice belt. All right, started. We're going to do some mental math reflexes. We haven't done a whole lot of that in a while. But in your math journal or on your iPad, what would the number 1 followed by 3 zeros look like? A 1 followed by 3 zeros. If you were thinking or wrote down the number 1,000, you are correct. Now remember, when we have 1, 2, 3 places values in, we've always got to separate it with a comma. Now, what would the number 78 followed by 3 zeros look like? If you said 78,000, you are correct. Taking a look at the next one, 214 followed by 6 zeros. If you said this number, 214 million, you are correct. Your math message today, we're going to go ahead and take a look at Math Journal, page 214, and I want us to look at a few of the examples together. Now remember, calculations with exponents should always be done before any other operation. We're going to be taking a look at order of operations in the next. I'm going to give you some time to go ahead and get started with 1 through 5. And 6 through 10. You can go ahead and pause the video at this time. And I'm going to go ahead and get started on what the number patterns are going to be for 1 through 10. If we're taking a look at number 1, which was already done for us, 10 to the second power. Remember, the second power tells us how many times to multiply our base by itself. Once, twice. 1 times 1 is 1. We have to add our 2 zeros, which are right there. Now, number 2, 10 to the third power. It's telling us to do 10 times 10 times 10. The exponent is to the 3 of the third power, which is going to be 1,000. 10 to the fourth is going to be the same as 10 times 10 times 10 times 10, which is going to equal 10,000. 4 and 5 you should be able to do on your own. Now, taking a look at 6 through 10, if you've already previewed the scientific notation, you're going to say, hey, there is a number times a power of 10. That's scientific notation. You are correct. So 6 through 10 are examples of scientific notation. Remember, if we're going to take a look at number 7, 3, which is already written right here, and we're going to do 10 to the third power, which is 10 times 10 times 10, which is what's 1 times 1 times 1? Well, that's 1. Multiply by your 3, we get 3. And now we have to go 1, 2, 3 zeros to get 3,000. Taking a look at our next one, 4 times 10 to the fourth power. Well, we're first multiplying it by 4, and then 10 times 10 times 10 times 10, running out of room there. Getting us our answer. What is 4 times 1? Well, that's 4 times 1 is 4 times 1 is 4 times 1 is 4. Now we have to go ahead and add our zeros of 1, 2, 3, 4. Remember, our comma needs to go in 1, 2, 3 place values, so we should have an answer of 40,000. You should be able to go ahead and continue number 9 and 10 on your own. Taking a look down below, when you write a number as the product of a number, which is that first number written right here, and a power of 10, which is right there, you're using scientific notation. Scientific notation is a useful way to write large or small numbers. Many calculators might display numbers like 1 billion or larger with some scientific notation. So it's really important that we understand what it might look like if it is written this way in a calculator. Now we're going to go ahead and take a break from scientific notation, and we're going to go to expanded notation. So if we're going to take a look at the example 236, we're going to write it in expanded notation. We should see that the base word is expand. We're stretching that number out. So we're going to take a look at each place value in the number 236. So let's go ahead and first take a look at this place value of the 2. Now, is it worth 2? No. It's actually going to be worth 200 because it is in the hundreds place value. And how many hundreds do we have? Well, it says 2. Now we're going to add that to the next place value, which is the 3. Now it's not just 3, but it's in the 10 spot. So if we had 3 tens, think about 3 $10 bills, we have 30. Now finishing up that last place value, which is 6. And if you're thinking about place value, it is in the 1 spot. And so 6 ones, if you had 6 $1 bills, how much would you have? That is 6. Now, expanded notation is a way to look at the numbers, stretching them out. Now, if we were to go ahead and add all of these together, we would get that number of 236, which we already started with. All right, page 217 in your math journal, what you're going to be doing as an in-class activity, is going to be taking a look at expanded notation. Thinking about expand. We're stretching it out. We're taking a look at the example right here of 2,784. First off, we're going to start out with thousands. How many, because this is the thousands place value, how many thousands do we have? Well, it's 2,000, 2 1,000s, which is equal to 2,000. Taking a look at 7, what place value is it? It's the hundred. So 700, $700 bills would be 700. 8, our next place value, that is in our tens place value. If we had 8 tens, that would be 80. And taking a look at our last place value of 4, and it's in our ones place value, 4, and the 4 ones would equal to 4. So writing this into expanded notation as an addition expression would look like 2,000, oops, and that should be a plus sign, not a comma, plus 700 plus 80 plus 4. Now, B says write 2,784 expanded notation as the sum of multiplication expressions. What this is asking you to do is taking a look at this column. So, I would say we have to do 2 times 1,000. And then we're going to add 7 times 100. We're going to add that to 8 times 10, and adding that to 4 times 1. Some of you might be confused on how we got there. We're taking a look at, there's a correlation, or there's a relationship between these two numbers. 2 times 1,000 is 2,000. 7 times 100, 700. 8 times 10 is 80. 4 times 1 is 4. Now, down below, it's going to ask us to do the powers of 10. So representing the same thing that we just did in B, but with powers of 10. So that would be 2 times, well, 10 to what power is 1,000? It's the third power. We're going to add that 7 times 10. Well, how do we get to the hundreds with powers? Well, it's the second power. We're going to add that to 8 times 10 to what power? Well, it is going to be to the first power, or we can just leave it as nothing. And then the same thing with 4. Now that we have shown you a couple of the steps, you should be able to complete the rest of page 2 for your in-class activity. Page 215 in your book today is kind of an interesting page. It talks about when things in history have actually happened. And now they're not just going to tell us 5 million years ago. We're going to be taking a look at scientific notation, which is, remember, using a factor of a number, and we're multiplying that by a power of 10. So go ahead and read this section on your own. You're going to have to pause your recording. All right, going ahead and taking a look now. Number 1, Earth was formed 5 times 10 to the 9th power. Well, what does that really look like? How many years ago was that? Well, 5 is going to be our number, and we're going to have that many zeros. We should have learned that from lesson 7.2. So we're going to have to add 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, every 3 place value is in, we should have a comma. So if we're taking a look, what is this number? Well, here are hundreds, thousands, millions, here's billions. So we're talking about 5 billion years ago, our Earth was formed. Kind of interesting to see that fish appeared before other dinosaurs kind of appeared. And you can see when the dinosaurs became extinct and so forth. Give yourself some time. Take a look at this page. It's very interesting to see when things actually... You have to use the numbers that you had, that you're thinking about for these. As your in-class activity, you're going to be taking a look with a partner at page 216. What you're going to need to do is to help you with this page. So number 1 is equal to, we said, 5 billion. And how we got 5 billion, this is our billions column. Go ahead and write in all of your data first, and then answering your questions. This is what you're going to be doing for in-class activity to help you with it. Now, just taking a look, another example of something. The area of Alaska, we're going to be talking about square miles here, is 6 times 10 to the 5th power. How is 6 times 10 to the 5th power written right now? If you said scientific notation, you are correct, because we have a factor of a number and we're multiplying it by a power of 10. Scientific notation. What does that look like in standard notation? Well, 6 times 1 is 6, and we have to add our 5 zeros. 1, 2, 3, 4, 5. So the area of Alaska in square miles is 600,000 miles. Now, instead of writing this out in numbers, how could we write it in number and word notation? I could say 6 100,000. So instead of writing it all out with zeros, I can say 600 and then replace the rest of it with words. So this was kind of a little bit of a review of some of the things that we've already talked about. Scientific notation, number and word notation, and standard notation. Here's also another review with using place values to rename some numbers. If we were talking about 1/10 of 10, how much would that actually be? So if we had 10, we would divide it into 10 equal groups, and we're talking about one of those groups. How much is going to be in each group? 1. 1/10 of 100. So if we had 100, and we put it into 10 groups. How many in each group? 10 times 10 is 100. If we're talking about one of those groups, that is going to give us an answer of 10. If we're looking at 1,000, 1,000 divided by 10 is going to be 100. If we're looking at one group, that is 100. So another, our brains thinking and going. Another review that I would like you to do for your in-class activity as part of your homework is looking at fractions. For your math boxes today, you're going to have to do number 1, 2, and 3. Taking a look first at number 3, what they're asking you to do is find an equivalent fraction. Remember, whatever you do to the bottom, you need to do to the top. Using your SRB pages to help you as well. Number 1, circling the fractions that are equivalent. Think about, how do we go from 3 to 6? Well, is that the same way you went from 8 to 12? If it is, then they're equivalent. If you multiplied 1 by 2 and 1 by 3, they're not going to be equivalent. Hint, there might be more than one answer there. And taking a look at it in another example of using fractions, it is a word problem. Think about the question, what is it asking? Are you going to be adding your fractions or subtracting your fractions? Well, this concludes the end. I hope that you are understanding scientific notation. Go ahead, go back to my website and look at that awesome scientific notation song again. Look forward to working with you in a little bit on scientific notation.